So they built a robot that you'll see that Elaine, I think, almost cried yesterday when she had to take apart the robot. They bonded really closely with this robot. You'll see it's quite an amazing robot.
Hi, I'm Elaine. I'm Colby.
And I'm Yannan.
And for our final project, we decided to make a robot that provides navigational automated assistance for the visually impaired, or Navi for short. So around the world today, there are around 36 million people who are legally blind, and this number is increasing by 2 million each year. And one of the ways that blind people get assistance to navigate around a place is through a seeing eye dog. So basically how this relationship works is that the blind person knows about which way to go and how to get there, and the dog helps them get there safely. So does anyone want to guess around how much it would cost to provide one person with a seeing eye dog? 5,000? Any more guesses? 30? Yeah, actually it costs anywhere from around 25,000 to 42,000. Therefore, our goal of this project is to create a cost-efficient robot using the Arduino Uno and Scribbler 2 to provide the same functions. And this is how it works. So the user will have a small remote, and whenever a button is pressed, it sends out an infrared signal. And the Arduino on top of the Scribbler has a sensor that can pick up the signal. And the algorithms in the code convert the signal into a number, which the code knows, depending on the number, it will turn on a different combination of 3 LED lights. We place the LED lights in front of the Scribbler's built-in light sensors like this, and the Scribbler knows that depending on what combination of light sensors are activated, it knows what action to do, so to move forward, turn right, left, or to beep, etc. We also included a function that utilizes the infrared sensors on the fluke attached to the front of the Scribbler, which can, it sends out infrared signals and can receive them, and depending on how much is received, it knows its proximity to an obstacle. And this tells the user if an obstacle or something else is in front of them to keep themselves. And then this is how the code allows it to do that.
So on the Arduino Uno microcontroller, we programmed it using C. As you can see here, this is part of our code. So we imported the IR remote library and the password library. So the IR remote, when you press it, each button sends out a different signal, and it'll go through this algorithm, and then depending on which case, it'll do a different set of actions. And for the password, you have to enter a password to start using your robot. And our Python, the Scribbler 2 robot was programmed using Python, and we imported the Mara library so we can control its motors and then its IR sensors and its eye sensors.
So basic hardware consists of the Arduino Uno, which is pictured right here, and the Scribbler 2. And this is our basic circuit diagram, and here you can see the 3 LED lights, and this is the IR sensor. And through this project, we got to our results and a lot of trial and error. So one of the main things that we had to fix is how to get the Arduino Uno to communicate with the Scribbler 2. So in the beginning, we had the 3 LED lights in front of the Scribbler's camera. So basically, it would take a picture and then process this image and figure out which way to go depending on the light. However, image processing is actually a really slow process, so we had to figure out how to make it quicker. So we actually took the LED lights and plugged it, or put it right next to the Scribbler's light sensors on the back. And basically, the Scribbler detects any changes in lights, and therefore this process is much faster than image processing.
So in conclusion, our project was generally successful. The robot's capable of detecting some obstacles, and then you can choose where you want to go after that. And it responds properly to signals from the remote, and it'll flash different LEDs. Also, as it moves, it'll beep, so you'll know where it is, and there's a panic button so that you can find it if you lose it. And the robot is generally cost efficient, and there are some ways that we can improve it, and further research, as Colby will mention in the next slide.
Some ways we could improve this robot. Firstly, we were thinking that we could include a docking loop of sorts with the robot that the user could place in his or her room, and each night when they go to bed, they could press a button on the remote, which would cause the Navi, the Scribbler, to either using IR sensing or color detection, find the box and go into it. And this would allow the user to find the Scribbler in the same place each morning when they wake up, so that they wouldn't lose it. Another thing we were thinking we could use color detection for would be to detect the yellow color of the mouse usually found at crosswalks. This could detect the user that they're near a street and are about to cross. And finally, we wanted to improve password protection so that the user could set and input a password using only the remote without having to put it into the code itself. This is our demo video.
So this is inputting the password, and you get it wrong, what you keep on.
Right now it's beeping because it detects the obstacle in front of it. So on the back there's an emergency panic button. So basically if you press the middle button on the remote, it'll start beeping.
So for this, Elaine actually like took it away from Colby and hid it somewhere. So yeah. So we'd like to thank our professors, our teacher fellow, and our teacher assistants. And thanks for listening.